Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Today our group will presenting our poster. The title is Incinerator and Emission Control. This topic is important because incineration is widely used for waste management, especially for municipal solid waste, hazardous waste and clinical waste. But it also raises serious environmental and health concern if not properly controlled. First of all, my name is Abdul Razak Lokman and our group members is Muhammad Naqib Syahmi bin Rosli and Muhammad Arash Jafni bin Muhammad Syarizan.
So basically, what is incineration? Incineration is a thermal treatment process where waste is burned at high temperature. The main purpose of incineration is to reduce waste volume, destroy pathogens and stabilize hazardous substance. And because of these advantages, incineration is commonly used for medical waste and hazardous waste. However, the major issue with incineration is the release of air pollutants, which can negatively affect air quality and also public health. Therefore, emission control systems are essential to ensure incinerators comply with environmental regulation.
Okay, now I will move on to the environmental issues associated with incinerations. One of the main pollutants is particulate matter, or PM, which can penetrate deep into the lungs and cause respiratory and cardiovascular disease. Next are acid gases, such as sulfur dioxide and hydrogen chloride. These gases contribute to acid rain and can cause corrosion to buildings and infrastructure. Another major pollutant is nitrogen oxide, or NOx, which play a key role in smoke formation and ground level ozone. Incineration can also release heavy metals like mercury, cadmium and lead. These metals are toxic, can accumulate in the environment and pose long-term health risks. Finally, dioxins and furans are extremely dangerous pollutants. They are persistent, bioaccumulative and carcinogenic even at very low concentrations. Then, for impact of emissions, the release of these pollutants leads to several serious impacts. Firstly, it causes degradation of air quality, especially in communities located near incineration facilities. Secondly, pollutants can be deposited onto soil and water bodies, leading to contamination of ecosystems. Thirdly, long-term exposure increases public health risk, including respiratory illnesses and cancer. Lastly, these pollutants can result in ecosystem damage, affecting plants, animals, and overall environmental balance.
So for these slides, we are going to talk about emission control technologies. And to minimize these impacts, various emission control technologies are used. For particulate matter control, fabric filter or baghouse systems are commonly applied, and they can remove more than 99% of particulates. Other systems include electrostatic precipitors and cyclone separators, which are often used as pre-treatment. And for acid gas control, wet scrubbers are used to neutralize acidic gases using alkaline solution. And alternatively, dry and semi-dry scrubbers inject lime or sodium bicarbonate to remove acid gases. And for NOx reduction, two main technologies are applied, SNCR and SCR. For SNCR, which offers moderate efficiency, and for SCR, it provides the highest removal efficiency using a catalyst. And to control dioxins and heavy metals, activated carbon injection is widely used. Additionally, rapid quench cooling is applied to prevent the reformation of dioxins after combustion.
Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Arash Jafni and I will continue our presentation today. Alright, next is about mitigation strategies. So beyond technology, effective mitigation strategies are also crucial. Most modern incinerators use a multi-stage emission control system combining baghouse filters, scrubbers and also activated carbon injection. Proper waste segregation is important to reduce chlorine content and heavy metal loading before incineration. Maintaining optimized combustion conditions, typically above 850 degrees Celsius, ensures complete burnout and minimize pollutant formation. Furthermore, the use of continuous emission monitoring system or CEMS allows real-time monitoring of emissions. And lastly, regular maintenance and operator training are essential to ensure the system performs efficiently. Alright, in conclusion, incineration is an effective method for reducing waste volume and destroying harmful pathogens. However, without proper emission control, it can pose serious environmental and health risks. With the implementation of modern emission control technologies and proper operational practices, pollutant emissions can be reduced to well below regulatory limits. Therefore, incineration can be considered a safer and more sustainable waste management option when it is properly designed, operated, and monitored. Alright, so these are the references that we used in order to make this poster. Right. And that's it, that's all from us. Thank you for listening to our presentation today.